So we're going to go ahead and simplify these expressions over here by rationalizing the denominator. So if you remember from a couple of years ago, when we say rationalize the denominator, effectively what we're saying is if you look at the bottom of the fraction, we don't want to have any of those irrational numbers or those surds. So we're going to apply a technique to each of them so that we're going to arrive at effectively the same number as what we have in the question, but it's not going to have a surd somewhere on the bottom of the fraction, i.e. we're going to rationalize the denominator so there's no more surds. So let's have a look at it, right? So for part A, I might just zoom in because it's easier to write when it's zoomed in. So for part A, we've got 1 over the square root of 5. So this is the most simplest type you could get. And all we do, if you remember, is you multiply by another fraction, and it's going to be whatever the denominator is going to be for these types. So it'll be root 5 over root 5. So this is the technique to rationalize the denominator for these ones. So we just multiply that, right? So our answer is going to be a fraction, of course. So we have 1 times root 5 on the top, so that will be a root 5. Root 5 times another root 5 is just going to be a 5, so that goes on the bottom. There we go. We've rationalized the denominator. There's no more surds on the bottom of the fraction, so that means our answer is equivalent to saying root 5 over 5. So just a key important point here, which I might just make, just bear in mind that this and that are exactly the same number. There is no difference whatsoever. It's just that it looks different because we have done a little bit of simplification there so that there is no surd on the bottom, but they are exactly the same number, the same decimal if you're going to put into the calculator. Now we're going to move on to part B, and we're going to have a look at a slightly different type. So for part B, we've got 3 all over 2 plus root 5. Now, we're going to do the same thing. We're still going to go ahead and multiply by a fraction. But this time round, what would work is to multiply by the conjugate. So when I say the conjugate, I'm still looking at the denominator, and it almost looks like I'm multiplying by the same denominator, but I'm just going to reverse the sign and do the opposite to my denominator. So if it's 2 plus root 5 being my original denominator, my conjugate would be 2 minus root 5. So that's the trick to get rid of the surds. Let's multiply out so you can see exactly why that works. So we're going to equals, we're going to have one large fraction, so on the looks of it. So the numerator is going to be 3 lots of 2 minus root 5. The bottom will look like this. So you have your 2 root 5 multiplied by your 2 minus root 5. All right. Now the reason why this technique here works when you multiply by the conjugate, in fact, as I do that, I might just quickly simplify and expand the numerator. So 6 minus 3 root 5 looks right to me. It's because the bottom will always become a difference of 2 squares. So we're going to expand using the difference of 2 squares. So 2 squared is 4. Minus root 5 squared is 5. So that becomes my denominator. Notice there's no more surds. That's the whole point of multiplying by the conjugate. Now 4 minus 5 is negative 1. So I can think of this as 6 minus 3 root 5 all over negative 1. Now leaving my answer like that just looks a little bit awkward, right? When you just have a negative 1 on the bottom of the fraction. So one thing I can do is this can be thought of as negative of 6 minus 3 root 5, sorry. Right, so we can push that negative back to the numerator if we would want to, and it's advantageous to do that here. And then we're going to expand, right? So it's going to be negative 6 plus 3 root 5. So not only have we gotten rid of a nice, we've gotten rid of that sort of surd in the denominator, it actually turns out to be no longer a fraction, coincidentally. All right, so long story short, let's just go back and zoom out. So we multiply by the conjugate. So you look at whatever's on the denominator and you just do the opposite sign, and then a difference of 2 squares will appear. All right, let's have a look at this last one though. We're going to follow exactly the same procedure. So for part C, zoom in a bit more. We've got root 2 all over root 3 plus root 2. So we're going to do exactly the same thing. We're going to multiply by root 3 minus root 2, so my conjugate, root 3 minus root 2. Equals, big fraction, what would the top look like? you'll have root 2, lots of root 3 minus root 2. The bottom, difference of 2 squares again. So although this last one here looks like it's a slightly different type because we have 2/3 on the bottom of the fraction, same method though, multiply by your conjugate. Numerator, let's see what the top simplifies to. When I expand, root 2 lots of root 3 is root 6. Root 2 times negative root 2 is minus 2. The bottom of the fraction, like I said, difference of 2 squares. Square that, you get 3. Minus. Square the root 2, you're going to get 2. Further simplify. Root 6 minus 2, all over 3 minus 2 is 1, which means we don't really have to write that down as a fraction. This just turns out to be root 6 minus 2. So once again, just like in part B, I might get both of those examples there in short. So when you have a couple of terms in the denominator, so like a 2 plus root 5 or a root 3 plus root 2, multiplied by the conjugate, a difference of 2 squares will appear. Simplify that, your denominator will no longer have a third. Hey everybody, if this video helped you, make sure you subscribe to the channel. It supports the channel and helps me keep making more free content for you. I'll see you guys next time.